Okay, our last cycle that we need to deal with is called a heat pump cycle. And you may have heard of a heat pump before, but a heat pump is, we're going to draw the same diagram that we had before. And we're going to draw this here. We're going to have a high temperature or hot. And we're going to have a low temperature or cold. Okay, and what's going to happen is that a heat pump, our heat pump cycle, that we are going to analyze, we are going to have this coming in here. We're going to have work in, or we have to power a heat pump. And what we're going to have is Q in and Q out. And you may look at that and say, Dr. Wanklund, that's exactly what a refrigeration cycle is. And you are exactly correct. It's the same thing as a refrigeration cycle. The difference is in the refrigeration cycle, we were concerned about the Q in. In the heat pump cycle, we're concerned about the Q out. Okay? So that's now the big thing. Now we're concerned about up here. This is going to be what we're looking at. But the analysis is going to be largely the same. So we're going to say delta E is equal to Q minus W. This is going to go to 0 because we know that the energy, the properties remain the same as we go around there. So we're going to have 0 is equal to, what do we say? We say Q in minus Q out minus a minus work of the cycle. And then we're going to find that the work of the cycle is equal to Q out minus Q in. Okay? Same exact thing. Same thing as refrigeration. No difference. Where the difference comes is when we evaluate the coefficient of performance. Okay? The coefficient of performance. Which we're going to call gamma. Okay? It's still going to be what do we want over what do we have to give. But in this situation, what we want is for us to pump heat. We want heat to go into your situation. So we're going to talk about Q out. What do we have to give? Well, we have to plug this in. We have to provide it with some power. We have to do this work at the cycle. Or we could write this as Q out all over Q out minus Q in. Okay, again, you can't do anything more algebraically with this. The denominator doesn't break up into a nice simple form like it did with power cycles. And just like we said before, we could put rates over all this. Do this on a rate term, and this will be fine as well. Okay. Again, your heat transfer, your heat pump. This can be gamma should be greater than 1. Now, if it was a cold day outside and you took your refrigerator and instead of using it as a refrigerator, if you put it in your doorway and you opened up the doors and you let the air from the outside come in and you let then the back of the refrigerator was heating up your house, that is in a way a heat pump. The difference is the refrigerator has been made a certain way that we're trying to maximize the Q in. And if we were to jimmy with that refrigerator, we could work in certain ways that we could maximize the Q out. That's very similar to what they're doing. In fact, you can buy for houses refrigerator heat pump, air conditioner heat pump units that are dual purpose units. And all they are going to do is you're going to have a difference of way that the fluid flows through the system is what is going to cause it to be a heat pump or cause it to be a refrigeration cycle. So for climates with moderate heating and cooling needs, heat pumps are really nice. Again, we're not going to go into the details. Thermo 2 gets in a little bit more. We can get into a heating and air conditioning class. We get into more about why we would choose a heat pump. We just wanted to understand the basics of what a heat pump is, okay, and what it does, about what these cycles do. Now, let me talk to you just a moment here when we have about I'm done with the lecture material here. And this semester provides me with a unique opportunity in that I have this in-class portion of time. So usually right here at the end of this lecture, I'm going to be doing just as many examples as I can really fast. And what I've decided to do is I'm not going to do any examples for this lecture. I'm going to leave the examples for the in-class portion and record that, and then I'll be posting that up there. And you're going to have a long weekend because this homework today's Wednesday, would be due on Monday. It's not due on Monday. It's going to be due on due on Wednesday because there's no class on Monday. So this homework today is due a week from today. So I hope you watch this lecture. I hope you watch the in-person lecture, which has a lot of good examples. And the reason why I want you to watch that is because the wording of these problems can get people and trip them up. I will guarantee to put a cycle problem on the test. Guarantee to put a cycle problem on the test. And I guarantee the cycle problem on the test will have wording that makes sure that you have to understand the process, understand what QN is and Q out is, to make sure that you are aware and can handle the problem properly. Now, here is where it becomes difficult. Let's go back up here to this refrigeration cycle. If I say the cycle rejects heat, what am I talking about? I'm talking about Q out. If I say the pie rejects heat, what am I talking about? I'm talking about Q in. I use the same phrase, rejects heat, but I talked about it in two different perspectives. One was the cycle, and one was Q in. When you are analyzing these systems for your homework, you are analyzing the cycle. Remember, you're analyzing the cycle. You get too caught up into thinking about the refrigeration compartment or the room that you're in or the heat pump or something like that, that you're getting heat from the surroundings or from your system. You are analyzing the cycle, the guts of the system. Remember that. Okay, so we are going to emphasize that on Friday in our in-class portion. I hope that having that extra time, I can really solidify and work out any bugs that you might have here as we work through that. So I encourage you to look at your homework beforehand. Look at the homework I assigned today. Maybe start on it, write it down, come to class, let's talk about it, or watch that video. Let's talk about it, because these problems are, number one, going to be on this exam, and number two, I'm going to hit up again in chapter 5, and they will be on another exam. So let's make sure that we have these solid. All right. Until then, stay healthy, and we will see you on Friday.